Swayam Prabha. Digital India. Educated India.
Welcome. So, we were discussing about multiple linear regression model, right. So, our model was multiple linear regression model that we were discussing, multiple linear regression model that we were discussing, and our model was something like this: yi equals to beta 0 plus beta 1 x 1 I plus beta 2 x 2 I plus beta k x k I plus u I. And then we say that the interpretation of beta 1 hat, once we estimate the model, we will get beta 1 hat, beta 2 hat, like that, and the interpretation of beta 1 hat we were trying to derive from this delta of expectation y I given x I divided by delta x 1 I. So, that means for a unit change in x 1 I, y I changes by beta 1 hat amount on an average, keeping the impact of other factors constant, right, keeping the impact of other factors constant. That means, in economics many a time we have heard about the term called ceteris paribus. Ceteris paribus condition means keeping the impact of other factor constant. And today we are going to learn how to keep the other factors constant. That is what we are going to learn, how to keep the impact of other factors constant to get the net impact of x 1 I on y I, which is basically beta 1 hat, okay, beta 1 hat. And this we will explain with a data set, and before we deal with the data set, we will take one example. What is the example we are taking? We are taking this example where our dependent variable is child mortality rate equals to some beta 0 plus beta 1 female literacy rate plus beta 2 per capita GNP, gross national product, plus UI. So, these data is basically say state level data. Our dependent variable is child mortality rate, CM is called child mortality rate of ith state. And how is it defined? Child mortality rate, it is defined as number of death, newborn child death in 1000. Okay. So, child mortality rate is number of newborn child death in 1000, and then our first dependent variable is FLR, which is female literacy rate, okay, which is female literacy rate, okay, and then PGNP is per capita GNP. PGNP is per capita GNP, okay, per capita GNP. So, this is what we are trying to understand from this particular data set. First we will try to understand, why these particular variables are included in the model, why the child mortality rate, we are trying to explain the child mortality rate, and there as a determinants of child mortality rate we have included female literacy, literacy rate and per capita GNP. What is the logic? Now, as mothers become literate, they become more aware of how to give proper care to their child during the pregnancy as well as post birth. What to eat, what type of specific food to eat, how much time to give for rest, and what are the proper medicine to take, so on and so forth. So, these type of factors, so that means the care, how much care you take during and after, during pregnancy and after delivery, that will basically determine the mortality rate. If a proper care is given, then the mortality rate will come down, and we believe that as the mothers they become more literate, they become more aware of this type of things, they take proper care to their child, and as a result of which the child mortality rate comes down. So, that is the reason female literacy rate is included in the model. This is a state level data. So, we will be measuring how many women are literate at the out of 100 or 1000. Then per capita GNP, state level, it is some kind of indicator of per capita income actually. We believe that as income increases, then the female literacy rate will also increase, because female literacy rate has some connection with the state's income, and also higher the state's per capita income, we believe the standard of living of that particular state would be would become higher, and that at higher level of income mothers will be able to take proper care in terms of food, medicine, so on and so forth during pregnancy or after delivery. Because of this, in our model we have hypothesized, there might be many other factors, but we have hypothesized these are the two factors that is the most important factor determining the child mortality rate, right. And that is the reason we have included these two factors in the model. Now, here our objective is to get beta 1 hat, and what is the beta 1 hat? What is the interpretation? For a unit change in FLR, for a unit change in FLR, child mortality rate changes by beta 1 hat amount, keeping keeping the impact of PGNP constant. That is the interpretation. So, for a unit change in FLR, CM child mortality rate changes by beta 1 hat amount on an average, keeping the impact of PGNP constant, right. This is the interpretation. And what would be the interpretation of beta 2 hat then? For a unit change in per capita GNP, child mortality rate changes by beta 2 hat amount, keeping the impact of FLR constant. This is how we can interpret the coefficients in multiple linear regression model, right. And now we will see step by step what is the procedure that we must follow to keep the impact of other factor constant, right. So, we will write the model once again here. Child mortality rate equals to beta 0 plus beta 1 FLR for diet state plus beta 2 PGNP for diet state. So, first we will try to get the impact of beta 1 hat from this model. That means, we will try to keep the impact of PGNP constant. Now, if we think logically, this PGNP will have some impact on FLR per capita GNP, and then PGNP will also have directly impact on child mortality rate, since it is an explanatory variable, okay, explanatory variable. So, if we want to get the net impact of FLR on CM, then what logically we should do? Logically, if we think, then we can understand to remove, we have to remove the impact of PGNP from both CM as well as FLR, which is quite simple to understand. We want to get the net impact of FLR on CM. Net impact of FLR on CM. What is our objective? Objective is to get net impact of FLR on CM. That is what is our objective. And to achieve that objective, what we should do? We should then remove the impact of PGNP, remove the impact of PGNP on CM as well as on FLR. That we should do. We want net impact. So, we have to remove the impact of per capita GNP from both these, right. If we remove, then this child mortality rate would be purified from the impact of PGNP, FLR will also be purified from the PGNP, and then if we regress CM on FLR, we will get the net impact. So, this is our objective, net impact of FLR on CM, that is what we want to achieve, okay. And to achieve that, we need to remove the impact of PGNP on CM as well as on FLR. How to do this? So, step 1. To remove the impact of PGNP on CM, what we actually do? We will regress CM on FLR and we will run this type of regression. Let us say lambda 0 plus lambda 1 PGNP plus let us say U1. We will run this regression and get u1 hat. Now, once we regress CM on PGNP and collect the residual from that regression, what does this u1 hat indicate basically? If we recall, error term captures the impact of other factors. So, that means when we run this regression CM on PGNP and then collect u1 hat, that is basically that portion of CM which is unexplained by PGNP. So, that means u1 hat indicates the unexplained portion, that portion of CM, portion of CM which is unexplained by PGNP. That is all. Okay. So, that portion of CM which is unexplained by PGNP is basically captured by u1 hat. So, that means I can say u1 hat is nothing but the purified value of CM. It is also CM, child mortality rate only, but only after removing the impact of PGNP. PGNP will certainly explain certain portion of child mortality rate since we have included this variable in the model. So, you remove this by regressing. How to do that? Get the u1 hat which is basically the residual, which is that portion of CM which is unexplained by PGNP. Then in step 2, what we should do? We will run another regression where FLR is regressed on PGNP plus let us say u2. And from this regression what we will get? We will get u2 hat, right. Now, what does this u2 hat indicate? From the same logic, following the same logic, we will say that u2 hat is that portion of FLR that portion of FLR which is unexplained by PGNP, right. So, u2 hat basically captures that portion of FLR which is unexplained by PGNP. So, that means this u1 hat and u2 hat, they are basically indicating the purified value of CM and FLR respectively. Okay. So, that means what we can say that u1 hat and u2 hat represent the purified value of CM and FLR respectively. That means u1 hat is free from PGNP, u2 hat is also free from PGNP, right. And then in step 3, what we should do? We will run another regression of u1 hat equals to let us say gamma 0 plus gamma 1 u2 hat plus let us say epsilon. Okay. And from this regression what we will get? We will get let us say gamma 1 hat. Now, what would be the interpretation of this gamma 1 hat? Gamma 1 hat basically indicates for a unit change in u2 hat, on an average u1 hat changes by gamma 1 amount, gamma 1 hat amount. That means, the interpretation is for a unit change in U2 hat U1 hat changes by gamma 1 hat amount on an average. Okay. All right. For a unit change in U2 hat, U1 hat changes by gamma 1 hat amount on an average. But then what is U2 hat? U2 hat is basically the unexplained portion of FLR, which is free from PGNP. And what is U1 hat? U1 hat is basically unexplained portion of CM, which is free from PGNP. So that means I can say the interpretation as for a unit change in U2 hat, I will say that for a unit change in FLR, purified value of FLR, okay, what is the change in purified value of CM? That is nothing but gamma 1 hat, and that should nothing but, that is nothing but our beta 1 hat. So what we can say that actually beta 1 hat equals to gamma 1 hat. So this is how we can get the net impact of FLR on CM following these steps, okay, following these 3 steps. So the idea is, since we want to get net impact, that means the impact, net impact of FLR, we need to remove the impact of PGNP on FLR as well as CM. And how will you remove? Simply just regress both CM and FLR on PGNP, and then we need to collect the error term, predicted value of the error term. Since the predicted value of the error term captures the impact of omitted variable, that means we can say that at least this portion is not explained by PGNP. We are doing this and then we are regressing one error term on the other so as to get the net impact of FLR on CM, which is nothing but beta 1 hat. Okay. But in step 3, if you look at the equation carefully, in step 3 we made a mistake while specifying our equation. Look at step 3, U1 hat equals to gamma 0 plus gamma 1 U2 hat plus epsilon. This equation we made a mistake. What is the mistake, can you think of? In step 3, is there any mistake I have committed? I deliberately made a mistake for your own understanding, and now I am asking you to think, what is the mistake? Is this equation in step 3 theoretically correct?